Okay, axes, planes, let's practice, okay? Remember, the room has a perspective. We call this a global reference. The analogy I gave you in straight line world is north, south, east, west. The compass always points in the same direction no matter how you change your direction, okay? So a global reference is meant so that everyone is forced to see the same thing, okay? So anytime on the test I say global, automatically you should literally imagine like the room is like looking and like how does the room see spin? And what does the room see spin about, okay? So from a global reference, or the room's reference, what plane is this rotation occurring in? Frontal. Notice I said in, it's in the dimension of rotation. What axis is this rotation occurring about? Do you see the difference between in and about? Okay? The rotation is in the room's frontal plane. The rotation is about the AP axis. So on the test, you may get planes and axes confused. Don't do that. Right? Know what a plane is, and then know what an axis is. From the room's perspective, what does everybody see? And even if I say the room's perspective, once I communicate a global reference, we automatically see what the room sees. Does that make sense? Again, north, south, east, west. So what do we see from the room's perspective here? Sagittal rotation about a bilateral axis. What if it's not spinning? Then it's not moving in a plane. What if it's just going up, down, front, back, left, right? It's not moving in a plane. Planes are rotational dimensions. Okay? What about this? Rooms transverse. About the rooms? Absolutely. Okay? Your perspective is a local reference. So when I say local, that's like, whoa, let me see now who he's asking. Is it you? Is it your joints? Now all of a sudden that becomes relative. Okay? Local reference for the test is going to be your eyes. How do you see it? So if I'm in the anatomical position, the room and myself and all my joints see the same thing. But if I turn my head to the left, now the room's looking that way, I'm looking this way. My perspective is going to be different than the room sometimes. We would still actually have the same transverse view. But if I'm here and I spun, if I'm here and I do this, what does the room see? What do I see? We are both right. Neither of us are wrong because we communicated perspective. We get it? Okay. What would we both see the same, regardless of if I turn my head to the left? We both see transverse the same. Yeah. There's no rules that say we can't see something the same, but we just don't have to see something the same. All right. Now, let's move on to the meat and potatoes of today. 3 straight line dimensions. In mechanics, we get X, Y, Z. The X, the Y, and the Z comes at you, right? If you go see a movie in 3 dimensions, 3D, you put on your glasses, all of a sudden it's coming out at you, right? In that 3rd dimension. A regular movie, you're going to see the screen up, down, and left, right. But you put on those special glasses, and all of a sudden it has depth. Okay? What I want you to, and it's not even understand, I know you guys know this, but sometimes we have to just kind of make sense of it and be like, oh yeah, that's what Mr. Smith was trying to say back in high school. Every dimension has 2 different directions of motion in that dimension. What I mean by that is we have the x-axis, or x dimension, but can I move in the positive x or negative x? Right? I have interstate 10. That's 1 dimension, 1 road, but I can go east or west. Right? I can move 2 different ways. Now, when you're saying, well, according to Mario Kart, you could go in a lot of different directions. Well, If you don't travel on the road, then that's hypermobility and bad things can happen, right? It's the same thing kind of with your joints. Your joints allow motion in certain dimensions, and if you go away from that, bad things can happen. That's very similar. So, putting some thought into this. One straight line dimension, two different directions of motion. A second straight line dimension, another two directions of motion. A third straight line dimension, two more directions of motion. So it shouldn't be any different in rotational world. In fact, we have a word for rotational directions of motion. You know what that means? Yeah, clockwise, counterclockwise, you've heard that before. Those are two different directions of rotation. That's all that is. Now, typically we look at it as a clock, but think about it. That clock could be in the room's frontal plane, that clock could be in the room's sagittal plane, or if the clock's laying on the table, it could be in the room's transverse plane. That clock could also be in my frontal, my sagittal, and if I'm laying down, my transverse. So the key thing here is that when we're talking about human motion, and we have rotations that are going on, all of those rotations follow the same laws of mechanics, where it can only rotate in one or more planes, and each plane has two different directions of spin. You could either spin this way or that way. You could either spin this way or that way. Exactly. This way or that way. Here's the key, is that regardless of if I'm spinning this way or that way, the motion is going to be called something different, clockwise, clockwise, but the dimension of rotation is the same. It's in the same dimension. It's in the same plane. Just like whether you're going east or west on Interstate 10, you're still on I-10. Okay? So don't get confused if I spin this way, and if I spin the other way, don't say, oh wait, he went a different way. No, it's in the same dimension. Two different rotations, same dimension. Okay? All right. Now, let's get into how we can look at joint motions a little easier. What do you guys think about when I draw something like that? What's the first, like a character association? What do you guys see? Anybody? There's no right answer, guys. I'm just curious. What do you guys see? This right here. What? A donut? I love a donut right now. I see donut. A wheel, maybe if I'd have done this. Back in my day, we had things called records, right? 8 tracks. And horse and buggies. I'm old, man. So check this out. Let's pretend this is a record. Y'all know what a record is? Right? It spins around. Now, obviously, you don't have the record player like this, but I can't show it to you if it's like this, right? So I'm rotating it. So you can imagine you're looking down at the record spin around. Now, as the record rotates, it could rotate this way, or it could rotate that way. It can't rotate in both directions at the same time. Right? It can rotate one way, and we can slow it down and re-spin it the other way, but it's in the same dimension regardless of how it's spinning. If the record is not spinning, is it moving in a dimension? In a rotational dimension, or a plane? No, it has to have spin to move in a plane. Now, as the record rotates, clockwise, counterclockwise, or clockwise or counterclockwise, all of the mass, above, below, left, right, front, back, that all cancels out. So the mass of it has no translation. That's what we call pure rotation. When it's moving, but it's not going anywhere. It's moving, but it's not going anywhere. Imagine if you had a car that was getting the oil changed. and I don't think sometimes they do that. Sometimes they do it on the bottom, sometimes they lift the car up. But they lift the car up and they just spin the tire. The tire's moving, but it's not going anywhere, okay? That's pure rotation. We have a few places that have pure rotation, more pure. We can have, like, our head can do this. It's moving, but it's not going anywhere, as opposed to moving my head like this. Now my head is going forward and down, up and back. See the difference? When I do this, yeah, it's more like spinning a basketball. This kind of stuff is more pure rotation compared to this kind of stuff where I'm going somewhere, going down, coming up. This kind of motion is more pure rotation compared to this kind of motion where my arm is going somewhere. It's going out and going up. You see the difference? Apple, banana, strawberry, sledgehammer. What looks different? So, pure rotation. So let's look at what would general motion look like. In other words, a combination. So imagine if I just took a silver Sharpie and I just drew a line on the record with a little hand. So we still have the record, but we only have one thing that really stands out. If this traveled across, well, now the center of mass isn't here. If I just had one section, the center of mass would be there, and as it would rotate, it would go forward, and then here it would be going up, and then here it would be going back, and here it would be going down. So a lot of our human motion is going to have a combination of rotation and going somewhere. However, we don't communicate human motion with linear terms. I mean, we can, like when you're doing lateral races with somebody, they bring it up, there's nothing wrong with that. But in terms of communicating joint motions, we don't communicate the linearity because the linearity changes. I'm going forward and up, well now I'm going up and back. It changes as you rotate. But what doesn't change is the rotational component. The spin stays the same, clockwise, counterclockwise. So that's why we term things like flexion, extension, add, from the rotational component of that motion, because the rotation doesn't change, even though the straight line components may. Okay? All right. Let's go back to our rows. I like to introduce concepts in straight line world and then modify them to rotational world because we're more familiar with straight line world. We live in a world of straight lines and we're more comfortable in a world of straight lines. Before I start, I just want to say, please rewatch these lectures if you need to. Okay, because this is the part that some, I'm not going to say all, but some students kind of start to, it's not that bad. Let's give an analogy. If you are home, what is home? You gotta watch those slanted tables, man. They get you. What is home? Well, for us, home is anatomical position, right? But for my analogy, home is going to be Lafayette, Louisiana, Bourgeois Hall, where you're going to school right now. That's home base. That's our reference. Because if you think about it, what does east or west really mean? That's a relative term. Lafayette is east of Lake Charles, but Lafayette is west of Baton Rouge. You know, in other words, it could be both, but you have to compare it to something else. You can't just say Lafayette is east. You have to give it a reference. You have to. Okay? So here's my straight line analogy into a rotational world. If home base is for us is Lafayette, and we compare position motion relative to where we live, relative to where we are, well, a lot of things start to make sense now. Baton Rouge is east of us. And when I get on I-10, I can be traveling east from here, and yet my position is still east from here. Y'all like, dude, that's duh. Feel you. Let's say you forget something. You're going to spring break and you forget something. I don't know, maybe you forget sunscreen. I'm joking. Let's say you forget something important, like your Sprite. Let's say you forget your Sprite. You turn around, you're coming back to Lafayette. What's your position? Remember, position just means where you're at relative to something else. Your position is still east, right, of Lafayette. But how are you moving? You're moving west. If you give unto Caesar what is Caesar's, if you separate where are you at from where you're going, it makes a lot of sense. I am east of Lafayette, but I'm traveling west. That's okay. You don't have to have them line up if you communicate the two different things you're talking about. Where are you at? Where are you going? Can I be west of Lafayette? Sure. And can I be west of Lafayette while traveling east? Of course you can. Can I be west of Lafayette and traveling west? Absolutely. What if you are in Lafayette? Like you're here right now. Where is your position? You are home. You're not east and west of anything that you're relative to. This is home. This is your anatomical position. So let's make sense of this simple straight line concept in a rotational world. You have two very important positions in this class, anatomical, fetal. The road, the interstate, to go from anatomical to fetal position lies in the sagittal plane, your sagittal plane. Right? I'm not going to get there like this, and I'm not going to get there like this. So the road is sagittal. Clockwise and counterclockwise in the sagittal plane, we term flexion and extension. That's how those things get their name. Flexion is traveling the road to get you into fetal position. And extension is traveling down the road to get you out of fetal position. That's all it is. Okay? So let's look at some different things that can get me into a ball. My knee can help me get into a ball. My hip can help me get into a ball. My neck or my cervical vertebra can help me get into a ball. My trunk, my fingers, my wrists, my elbows, my shoulders, all these things can help me get into a ball. So here's the idea of what I'm trying to get to. If anatomical position is home base, and we know that position, where are you at, is relative to a starting position, anatomical. Well, now what I can do is I can say, am I closer to being in a ball at my shoulder, or am I further away from being in a ball at my shoulder? Meaning that from anatomical position, Lafayette, if I am anywhere here, I am more into a ball than when I was here. So that's what the term means when you say you are flexed. Someone is flexed. That's a means of position. Where are you at? Extended. That's a position term. Where are you at? Externally rotated. That's a position term. Where are you at? So the ED terms, like flexed and extended, those are position terms. Where are you at? You can be flexed and yet be extending. There's nothing wrong with that. I'm going to show you some examples. You can be extended and be flexing. There's nothing wrong with that. Where are you at and where are you going? Okay? This is a term of where are you going. Forgive my lack of spelling. I try. That's important, guys. Very important. where are you at versus where are you going? Things that end in ED, flexed, extended, abducted, adducted, protracted. It's a position. I'll give you an example of why this is important. When you guys learn what's normal, I say normal, but within daily limits of the average person. In other words, someone who's 7 feet, that's normal for them, but it's not normal for the average height. Does that make sense? Okay. So when you're going to learn what's normal, normal position, normal, then you'll be able to compare what's not normal. I'll give you an example. A lot of older people kind of walk like this, right? They are in a position of being protracted in their scapula and internally rotated at their shoulder. It's a position. But they should be over here, right? So you work with them to try to reposition themselves to be back home. Okay? Position, where are you at? Motion, where are you going? So let me put some teeth into this. Here is my shoulder in anatomical position. This would be Lafayette for all of my joints in my body. Anatomical position is a place. Shoulder flexion from anatomical. Now my shoulder is in a position of being flexed. All of this, it's still in a position of being flexed. Just like if I traveled east, it doesn't matter how I scoot back and forth, I'm still east of Lafayette. Flexion of my shoulder, I am flexed. Extension of my shoulder, guess what? I'm still flexed. How do we communicate this in verbiage? Just like you would traveling on the interstate. I'm traveling east from Lafayette, or I'm traveling west to Lafayette. And imagine if you passed Lafayette up. You'd be like, I'm traveling west to Lafayette, and now I'm traveling west from Lafayette. You know, you keep going, and now it becomes to from. It's the same thing with human motion. Flexion from anatomical, extension to anatomical, extension from anatomical. Flexion to anatomical, flexion from anatomical. That's it. Let's do hip. Left hip flexion from anatomical, left hip extension to anatomical, left hip extension from anatomical, left hip flexion to anatomical, left hip flexion from anatomical. When I'm here, I'm in a flexed position. My location is more to fetal than it was in anatomical. And when I'm back here, my position is extended. I am further away from fetal position back here than I was in anatomical. Some crazier ones. Now, I'm just introducing you to these concepts, guys. You don't have to know all these motions. We're going to get into these motions. Right lateral cervical bending from anatomical. Left lateral cervical bending to anatomical. Left lateral cervical bending from anatomical. That's how you do it. To, from. Flexed, extended, flexion, extension. So what you will need to know on the first test, okay? What you're going to need to know on the first test is sagittal plane position and motions that get you into a ball and out of the ball. And I need you to practice the verbiage, the terms. Guys, human motion is a new language. And anytime you're learning a new language, you have to make sure that you can communicate with someone, right? So that you know you're talking about the same thing. No miscommunications. Amputate right leg, that kind of stuff, right? So all we're doing is we're laying some foundations so that we can be able to discuss concepts of human motion with anybody in this field. That's all it is. It's like a new language. Another analogy is growing up in Elcom, my mom and dad both spoke French. They didn't teach me French because they wanted to be able to talk about me without me understanding what was going on. But I listened for my name and I listened for their tone. But I picked up little words. You know, you pick up a word here, you pick up a term there, you pick up... And that doesn't mean I can speak it fluent. So it's very similar. There's no doubt that you guys up to this point have picked up some terms, right? Flexion and flexed and abducted and elbow joint and femur, and that's cool. But what I have to do is I have to make all that stuff make sense. I have to put it all together so that we can take those terms and make poetry with it, so we can discuss it with no confusion. It's just so easy to play fast and loose with these types of verbiages, okay? We don't want to do that. I'll give you an example of fast and loose. On TV, when you're listening to sportscasters, they play fast and loose with a lot of terms, okay? Or when you're working with someone and they're like, well, what are the muscles you work on? Your glutes and your quads and your core and your hams. It's kind of the same ones over and over again, right? That's knowing a little bit, but not being able to maybe make poetry with it. So that's what this is about. So let's discuss all the different joints in the body that can get me into a ball, can get me in a fetal position. Okay? The first one is the ankle joint. The ankle joint can get you into a ball. And interestingly enough, it can do it two different ways. It's kind of cool. The first way that the ankle can get you into a ball is if you are weight bearing, if you're standing. Because if you're standing and you're going to get into a ball, you're not going to get up on your toes, right? You're not going to pull a Michael Jackson. Hey, look out. Ah, hey, hey. You're not going to do like this, right? You're going to do this, where that's going to happen. If you get into a ball and you lower yourself, you're going to have this kind of change at the ankle. That's going to get you more into a ball. We call that dorsiflexion, the motion. You think of dorsi, the top part, like a dorsal fin on a shark or on a dolphin, right? Your foot has a dorsum, the top part. So dorsiflexion is when the top part of your foot gets closer to the front part of your shin. Whether it's the front part of your shin going down or the top part of your foot going up, that change is the same. Remember, engineers don't have to worry about this kind of stuff. To an engineer, the door will always move about the wall. But in biomechanics, our wall can move about the door. That's what makes our stuff a little bit more crazy. Okay? This may answer some of your questions, like, I wonder why we have two different forms of flexion. That's what I like to do. I like to explain the whys. So there's another way to get into a ball. When you're not weight bearing, when your feet are off the ground, you get into a ball not by bringing the dorsum to the anterior part. You get into a ball by bringing the top part further away. We call that plantar flexion. So you think about a gymnast doing spins, right? Or if you're in fetal position, I don't know if you guys sleep like me, but you know, you got thumb in your mouth and you're not dorsiflexed. You're plantar flexed when your feet are off the ground, getting into a ball. So that's kind of cool, that the ankle has two different forms of getting into a ball. Some of them when you're weight bearing, some of them when you're not weight bearing. Okay? Here's the important thing. It's the concept of plantar flexion, dorsiflexion, plantar flexed. What's my position relative to anatomical? Dorsiflexed. Now, I'm typically not going to ask you questions when there's like ambiguity. All of these changes are going to be very obvious. So I typically don't ask like ankle kind of stuff because you don't have as much motion here as you do other places. But the concepts are still the same. Now, let me talk about another fast and loose terms you guys have probably been introduced to, and that's the term hyper. Like hyperextension, hyperflexion, hyper this, hyper that. Let's first of all think about what that term means. If you have a hyperactive child, right, they are excessively energetic. Anything hyperventilation, excessive ventilation, hypertrophy, it's excessive. Nothing about hyper means within normal limits, okay? So if you're traveling down the road and the road allows so much motion, so many miles, and they have lights, road stops, road construction, and you blow past that, you went hyper east. You went beyond a normal road. That's a bad day. It's the same thing for your joints. You have normal ranges of motion, and that's relative. I'm very tight, so my hips may not move like other people's hips. But when you go beyond that road, that's hyper, excessive. The easiest example is like a hyperextended elbow. Does that sound like something you normally want to do? No, beyond normal range of motion. And you can have hyperflexion beyond your normal range of motion. You can have hyperexternal, you can have hyper anything. Okay? But the key thing here is that what you don't have is flexion, extension, hyperextension. That's not hyper, that's not excessive. That would be arbitrary where you'd say, well, why don't I start like this? Extension, flexion, hyperflexion? I mean, it's the same concept. Hyper works the same in all cases. There's no exceptions. It's beyond normal ranges of motion. But we don't say right lateral, left lateral, hyper left lateral. No. It's right lateral, left lateral, and then hyper right, beyond excessive. So all of these examples are going to be within normal limits and normal ranges of motion. And hyper does not exist in normal ranges of motion. Okay? Let's check out our knees. Not every joint has a Lafayette analogy to it. What I mean by that is in Lafayette, you could go east or west on I-10, right? You go in other directions. Some joints don't have that option. Some joints are all the way on one end of the road, okay? So what I mean by that is maybe Jacksonville is like the furthest east you could go in terms of town on Interstate 10. So imagine the knee is like Jacksonville, where in anatomical position, you can't go, you can only go one way is what I'm trying to get to. You can only go in the direction of flexion. So it's like you're all the way east, and the only way you can travel is west. Some joints are like that. The knee is one of those. In anatomical position, I can't go any further, so the only route I can take is the direction of flexion, getting me more into fetal position, getting me more into a ball. So in that instance where you have joints that are all the way at the end of a range of motion, then you can use the term in anatomical position, my knee is extended, because that's as far back as you can go. So it's common for people to say, you know, in anatomical position, my radial ulnar joint is supinated, my elbow is extended, my knee is extended. For these joints that don't have the option of going both ways, they're all the way at the end of their road. Okay? The hip is not one of those. The hip, I can travel in two different directions, right? So from anatomical position, I can have hip flexion from anatomical. I can have hip extension from anatomical. Here I'm extended. How do I know? Because I reference it from home. Where am I at relative to anatomical? I'm in an extended position. Here's another way to look at where are you at. If I asked you on the test, just an analogy, but if we establish Lafayette's home base and I say, you're in Lake Charles, where are you at? One way to prove where you're at is to say, how would I have to move to go back home? So in other words, if you're in Lake Charles, you'd have to drive east to come back home, which shows that you have to be west of Lafayette. So it's very similar. If I'm in this position, and I say, hey guys, what position is my left hip? All you gotta do is a simple thought experiment and say, how would I have to move my hip to go back home? Wouldn't I have to flex to go back home? Which shows me that I'm in an extended position. where are you at is a different question than where are you going. On the test, I'm going to have like pictures like this. Maybe better like this. Okay? What's the position of the hips? Flexed. And then I might say, okay guys, from here, because all motion has to be relative to position changes. That's what motion is, change in position. So I might say from there, is that Schroeder? I think that's Schroeder. Schroeder, the piano player. From there, Schroeder starts to move his hips back to anatomical position. What motion must happen? Hip extension to go back home. I might infer motion from anatomical. Schroeder sits down to play his piano. What motion must have happened at his hips? Well, if he was home and then he's in a flexed position, he had to have flexion to get there. Okay. So, watch this. Let's try to practice. Let's put some sense to this. Ay. No. Dang you, technology. Oh, denied. Approved. Happy Friday, y'all. The more quiet you guys are, the more obnoxious I'm going to get. Just giving you a heads up. I'm going to wake you up some kind of way. All right, check this out. Treat make sure everybody can see. Okay, so check this out. On the test, let me try to zoom in on this one. Okay, so on the test, I might say, there's two different ways that I'm going to ask you questions on the test. And even though this class emphasizes human motion, we can infer, we don't assume, but we can infer motion with two different types of pictures. One is a before and after. Guys, human motion, what we see as motion, is actually just a flip book of still pictures that our body processes and flips in our head and we infer motion from. That's all motion is. Motion is inferred. And we only have so many frames per second on our flip books. And if motion happens faster than that, we don't even perceive it. That's why like magicians and card people have the hand is faster than that. So my point is that when we're looking at motion, we can infer that from still pictures. So if I say, what motion did I have at my right shoulder from the left picture to the right picture? I started on the left and I ended in the right. And you say, well, I went from anatomical position to being in a flexed position. So I had right shoulder flexion to get there. I started off in Lafayette, I ended up in Baton Rouge, I had to travel east to get there. It's the same concept. Another way I can infer motion is one picture and then say infer motion towards anatomical or away from anatomical. What I mean by that is, if you see the picture on the right, and I say from this position, I start to rotate my shoulder to anatomical. I have to go back home. Well, that's right shoulder extension to go back home. If I start here and say I start to rotate my shoulder away from anatomical, well, then I have to have more flexion from that position. Like it really is that simple. One picture, to anatomical, from anatomical. are two pictures that are before and afters. Okay. Let's see if we get some more examples. So good. Okay. So if we're just looking at position, you know, fixed pictures might infer, but we don't necessarily exactly know. But what we do have are some clues in terms of position. That's all I'm going to do is talk about position. He is looking to his right relative to anatomical. In other words, if his neck was at anatomical, his chin would be lined up with a little icon, right? So he's here. So he's right transverse cervically rotated. That's a big term you guys are going to know down the road. I'm just giving you some examples, how I can look at his position and know how he has to be relative to anatomical. His left shoulder is abducted. Why? Because I'm being relative to anatomical position. His right knee is flexed, and his left hip is flexed, and his right hip is extended, and his trunk is right laterally bent. And just you're just looking at it and saying, where is he at relative to here? Now, that doesn't mean I know how he's moving. We'd have to have a before and an after, or a video to say whether he's flexing or extending. But position changes. Look at that, man. That's one of my favorite pictures. Anybody know who that picture is? That guy right there? Randy Johnson, the big unit. So let's look at some. His right hip is flexed, right? His right knee is flexed. His right ankle's a little planar flexed relative to anatomical. And this lies some illusions, guys. This is a good start to illusions. We do not reference human motion globally. We reference it locally. It's from the human person's perspective. So globally, you may look at that left hip and say extended. It's tempting. But if you tilt your left ear to your left shoulder and look at his pelvis, that hip, it looks like it's just going straight down, like it's still in anatomical position. Right? So I wouldn't put any money on his left hip position. It's just going along for the ride, as I like to say. His left knee's flexed, his left elbow's flexed, his right elbow's flexed, his right wrist is flexed. His shoulder is externally rotated a lot. So I'm not telling you have to know this stuff. I'm practicing the verbiage. That's all I'm doing. I'm practicing the verbiage. All you're going to have to know for the first test is this stuff. You're not going to have to know all that crazy stuff. First test is just getting you comfortable with understanding the difference between motion and position, and how you don't all have to be moving the same. What I mean by that is my right elbow could do something totally different than my left. It's okay. Exactly. I could start here and I could do this. I could do, right? So it doesn't have to be all or nothing. It's not going to be all or nothing. One side of my body may go into a ball, the other side may come out of a ball. We analyze motion joint by joint. We don't assume, we infer. Okay? So the take-home points from today's lecture is that if you don't quite get what I was trying to say earlier about two motions for every dimension, go back and rewatch it. That's important. In other words, if I say my elbow only moves in one of its dimensions, how many motions are we going to have to account for? Two. The elbow only has two motions. This is not elbow. If I say that the shoulder can move in all three of its dimensions, how many motions are we going to have to account for? 6. If I say the wrist can move in 2 dimensions, how many motions are we going to have to account for? Absolutely. Okay. Wrist flexion from anatomical, I'm in a flexed position. Wrist extension to anatomical, wrist extension from anatomical, wrist flexion to, wrist flexion from, extension to, extension from. Hyper. Small price to pay for education. Excessive hyperextension, hyperflexion. Okay, any questions? Make sure you sign the roll sheet. You guys have a good weekend. We'll see you on Monday.